So we decided to have a topic today with respect to the nature of the earth, and the focus here is looking at and expressing God's glory and the incredible precise workmanship that he's put into the earth so that we can have life, that it exists here. And as you'll see, and as I develop this, our earth is incredibly uniquely designed for stable biosphere and life to be here on the earth. I like to refer to it in many venues as creation story. We have an ancient earth and we have a magnificent creator. And our Grand Canyon book was the capstone of that in terms of the things that we've been doing with Solid Rock Lectures. I often think of this when I'm thinking about what God does in creation. Of course, going back to scripture always has value. I like this Psalms 104 quote, "He touches the mountains and they smoke." And then in Job 12:8, we have the opportunity to look to the fish of the sea and they will inform us, or let the fish of the sea inform you. My banner, my Zoom banner happens to be right over top of some of the wording at the top, so I didn't read that correctly, as you can see it. I reflect back on the greatest commandment that Jesus gave to us. Love the Lord your God with all your heart, with all your soul, and with all your strength, and with all your mind. I didn't realize until about a year ago that in the Old Testament, the heart, soul, and strength were emphasized, and Jesus added our minds to it as we came to the New Testament. So that was interesting to me. So we are to use our minds, which we know, but it was encouraging to me when I found that out in my Bible studying. Romans 1:20 describes the nature of creation and what it means in terms of understanding God. For since the creation of the world, his invisible attributes, his eternal power, his divine nature have been clearly seen, being understood from what has been made, so that they are without excuse. That is, anybody looking at creation can see the evidence of God being there. From the Old Testament, there's some wonderful words that are encouraging. It's the glory of God to conceal things, but the glory of kings to search them out, in Proverbs 25:2. Well, that's the ESV version. I really appreciated what was done with it in the Message. God delights in concealing things, and scientists delight in discovering things. Same verse from the Message. So that's what Peterson did with it. I really like that because as a scientist, that's encouraging. Going back to one of the early Christians who was significant in developing a lot of our scientific understanding of the solar system, and the chief aim of all investigations for the external world should be to discover the rational order and harmony which has been imposed on it by God, from Johannes Kepler back in the 1600s. Several Christians have written books about the context that we are on a very unique planet. In this case, the title of the book is The Privileged Planet by Guillermo Gonzalez and Jay Richards, How Our Place in the Cosmos is Designed for Discovery. And that's some of the things that I'll be showing to you. The universe is extremely fine-tuned for the Earth to be here, for life to exist, and for the opportunity for us to discover a lot about creation, and in that context then, God's character. In The Privileged Planet, which was published in 2004, they use the phrase, God has designed into his creation data recorders for us to decipher Earth history. And I'll be showing you some of those. When I chatted with you in 2017, I gave the context of the data recorders from radiometric dating. We won't have that topic today unless you ask questions, but some of the data recorders that we may likely get to of magnetic reversals in ocean basins fit that so perfectly as data recorders. Then Hugh Ross, a couple of years ago, not too long ago, released the book Improbable Planet, is the wording he used, How Earth Became Humanity's Home. I really love the topics and the titles of the chapters that he built into that book. If you haven't gotten it and read it, it's worth it. Some of the chapters include the construction materials. We're in the right neighborhood, and there he's talking about our solar system and our galaxy. It provides the foundation that is the Earth we're in, air conditioning having to do with climate, and then ready for occupancy. And that's not all of them, but he had catchy titles like this for all the chapters that he built into his book. This one released 2016, and I'm going to talk about two components in particular. God demonstrates his nature with having this Earth with a magnetic field which protects life from solar and cosmic radiation. And then number two, plate tectonics, because they exist here on this Earth, provides and maintains suitable conditions for life. And of course, plate tectonics in the first place gave us the continents on which we live. So I'll be describing some of those features. Oftentimes refer to the beginning of the Earth as the Big Bang. In the beginning, God created the heavens and the earth. A good friend of mine said, well, it wasn't really a random bang of chaos. He used the phrase the big flash because it was an incredibly precisely, finely tuned event in that creation event that astronomers and astrophysicists have understood. Now, I'll be looking a bit at several particular elements. So here's the periodic table. And the two dominant elements that existed at that time of the initial big flash were hydrogen and helium. If I remember correctly, it was something like understood to be 80% hydrogen and about 20% helium, with only minor amounts at that point of lithium. And then gradually the other elements were formed as stars formed and nuclear burning happened in stars. And then that eventually led up to all the 92 natural elements that we have here on the Earth. And I'll be talking about several of very significance for our conditions here on Earth. Iron and nickel are significant in the interior part of the Earth for a liquid core or outer core. And then I'll also be talking about uranium, thorium, and potassium, because those three are radioactive, or rather in case of potassium, most potassium is not radioactive, but it has one isotope that is radioactive that is part of the heating process when as those radioactive atoms decay when they're in the earth or wherever they are. So all the other elements, essentially, God formed in the way he designed the stars and supernova and what is referred to as nuclear burning. So certain size stars are big enough for hydrogen and helium to be fused into some of the heavier elements. And then ultimately, when stars go on their death keel, forming a supernova, there's that much extra energy included that ends up producing the heavier elements. And there I have the phrase at the lower left. There's hydrogen burning, helium burning, carbon burning, and then eventually leaning toward the explosive nuclear synthesis for the heavier elements that go up beyond iron and nickel. Picture of our sun to remind us of it burns because it's hydrogen being fused into helium on its regular producing the incredible amounts of energy that are there. Here's a diagram of a red giant star, and astrophysicists understand it to have layers inside because of the density differences and the burning process. They describe it sort of like an onion-like structure of where the different elements are. And before the phase of a nuclear a supernova explosion, when the elements beyond iron and nickel are produced, it has this characteristic that eventually goes in a huge supernova explosion. And there's a GIF file that kind of shows the context. The core collapses from one of these massive stars in a nuclear burning explosion, and that blast ejects material out into space. So when we see these beautiful, beautiful clouds that astronomers have taken of out in space, those have occurred from examples of these supernova explosions where all that dust and debris is blasted off in this production and the burning and producing and creating those heavier elements. So, context now of our Earth. Up on the right-hand side, I have the 3 dominant radioactive atoms that have long half-lives that are very significant in terms of the interior heating of the Earth. Back in the days when estimates, about 100 years ago, when estimates were being made about how old the Earth is, one of the scientists made an estimate how old the Earth might be because of the time it would take for it to cool down. If all of the heat generated inside the Earth came from the gravitational accumulation of all the stardust that ended up being formed into the Earth. What he didn't know at that time is a knowledge of these radioactive atoms that are a key component of heating the interior of the Earth because of the millions of years of decay of those 3 that have very long half-lives. So as the Earth was formed and God had the cloud that was forming the sun and all of our planets, in this region where the Earth is formed, there was just precisely the right amount of uranium, thorium, and potassium such that we could have this Earth that it segregates with the heating as it becomes hot enough for a liquid to occur in the interior of the Earth. So, an understanding from geophysicists that study the interior of the Earth, the inner core is considered and understood to be solid iron, so it's solid. Then the outer core is a liquid or semi-liquid, say, not liquid like water, but thick, heavy, a nickel iron liquid outer core that have convection cells in them. The outer core ends up heating the mantle, which is sort of a plastic or thick plastic, Play-Doh style, but at super high temperatures, of all the silicate minerals and the aluminum silicate minerals with lots of, here I've labeled and identified magnesium, iron, aluminum, silicon, oxygen, and has virtually all of the other metallic elements also. So the significance of the outer core is that is the source from which the Earth's magnetic field occurs and has developed. Geophysicists refer to that magnetic field as being a dynamo. That is, there's flow of currents that are generated by the movement of that nickel iron liquid. And this is one model that they come up with to represent what that field might look like at certain times. When it goes through a reversal that I'll be chatting about a little bit later, the reversals are such that then those lines of the magnetic field get contorted and they look rather different. There's enough uncertainty of what that happens. Here's another model of the geomagnetic fields and in the core, there with the solid core in the middle. So there's another model that geophysicists have developed as they continue to seek to understand the nature and why this magnetic field is generated by the migrating liquid of iron and nickel. Well, what's the significance? The significance is the magnetic field lines around the Earth, which are shown here schematically, with the North Pole and the South Pole, and the magnetic fields basically go out into space with large arcs. And when the solar wind coming from the sun reaches that magnetic field, the solar wind with damaging radiation gets diverted around the Earth so it doesn't come in to bombard the biosphere and bombard us right here in the surface with damaging radiation. Some of it does get down into the clouds in the northern hemisphere and the southern hemisphere, up toward the North Pole and down toward the South Pole, which is shown by the way these two green rings is an area where some of that solar wind can reach down to the atmosphere, and that's the source of the aurora borealis that is known in the northern hemisphere, and a similar kind of event in the southern hemisphere. And Kurt, again, thank you for putting the moving aurora borealis in your virtual background. I appreciate it. Okay, the magnetic field created in our Earth by a very unique composition of the stardust that made the Earth is a key component that protects life as we have it here today. Now let's look at plate tectonics, which helps maintain suitable conditions for life to exist. I'm going to share a little bit about the history of the Earth with the geologic timescale, which you've seen in my previous talks, and adding a little bit more to it now. As we get to the Grand Canyon a little bit later, I'll be referring back to this. And the geologic timescale, as it was developed in the 1800s, ended up being divided into a Paleozoic, meaning early life, Mesozoic, middle life, and Cenozoic, more recent life. And the rocks in the Grand Canyon are Paleozoic. Then Mesozoic is the time of the dinosaurs, which I'm now showing on this slide. And Cenozoic is the age of the mammals. Included here, early first life, and Hugh Ross in some of his writings, he and Fuzz write about early life, finding some of the earliest life back at about 3.5 to 3.8 billion years. And then land plants and animals, particularly happening and expanding dramatically, beginning with the Cambrian. And I'll have some other slides that talk about this. So here's the context then of the history of the Earth. Now this slide is showing across the scale of the screen the full history of the Earth. So up here on the right, we're at the present, and the numbers here are referring to billions of years. So 1 billion years ago, 2 billion years ago, 3 billion years ago, 4 billion years ago, and then 4.6 for the beginnings of the Earth as it coalesced. Now, in the early time, the atmosphere did not have oxygen. There was no free oxygen in the beginnings of the Earth as it was formed. It was carbon dioxide, it was water, methane, ammonia, So not suitable for life in any way, okay? As geologists have studied the history of the Earth, they have become aware that somewhere about 3.5 billion years ago, some beginnings of microcontinents were starting because of the heating from the liquid core to the mantle. So that gradually segregated lighter elements and with the circulation in the mantle. Then about 2.5 billion years ago, plate tectonics got going more significantly, and we have had several different cycles where the core continents were started in those early days, and then a little bit later I'll be talking about Pangaea and when that was developed, and I'll be showing Pangaea from about a point here a little bit before where this yellow line is. Now the yellow line that I've put, the vertical line here, that's the beginning of the Paleozoic, so that's about 540 million years ago. In the next slide, I also have this yellow line to give the context of sort of the time frame. So the next slide we'll have from the yellow line on to the forward to the present. Now notice this level of oxygen. I mentioned there was no oxygen in the atmosphere in the early history of the Earth, and oxygen was building up only very, very slowly as photosynthesis got started with the early life. Gradually carbon dioxide was absorbed into ocean water, and then eventually when photosynthesis got started, then it took the carbon dioxide and gradually built up a level of oxygen in the atmosphere, so that that level has been up to something close to the present for about 500 million years. This green band shows the rapid expansion of life, of more significant life beyond just microscopic bacteria from the early development of life. So this is the next step now, and there's that same yellow line. So here's the beginning of the Paleozoic, 541 million years ago, with the Cambrian, Ordovician, etc., on up through time. So Paleozoic, Mesozoic, and Cenozoic, up to the Racent. Here's what's referred to as the Cambrian explosion at the beginning, and that there was, remember from the previous slide, we could see that oxygen was building up toward its present level, so that gave the opportunity for many additional species to be created and live. So the rapid expansion of invertebrates during the Paleozoic, trees, marine plants, or marine animals and trees on land were very significant. Various different times there have been significant, extinctions, mass extinctions that have happened to the biosphere. The one we know about the most is this one about 66 million years ago, which was the end of the dinosaurs. But here the geologist who built this diagram has RIP for resting in peace for several different ones. So here's one that happened at the end of the Cretaceous. Here's one that happened toward the end of the Permian period. Here's one that happened in the Devonian. And here's one that happened back in the Ordovician. So there have been multiple times when there have been conditions on the Earth were such that extinctions occur. The other significant thing that I'll mention that's on this slide has to do with glaciations. We've been in a period now with ice ages for the last about 2.5 million years. But there were times when we see from the rock record glaciation periods. So there's one that's back in the Permian, here's one that's in the Devonian, and here's another one that was back in the Ordovician. So Earth has gone through these kind of cycles. And there I've identified the line for the Cambrian explosion, and here's the breakup of Pangaea that we'll be looking at here after a little bit. So, a brief overview then of the history of the Earth, early life before the Cambrian explosion. Whatever life was there was still microscopic and single-celled organisms. And then the rapid expansion of invertebrates, dinosaurs in the Mesozoic, and then mammals in the Cenozoic. Now, talking about the fine precision of the Earth, as a geologist, I focus on those things related to geology, but God's fine tuning includes the biosphere. So I can't help from at least mentioning the fact that the creativity that goes into DNA and the precision there that God has created is just remarkable. And I've had a number of years being involved with BioLogos, and I've had a chance to hear Francis Collins speak a number of times. And he's written a book called The Language of God, which is the story of his understanding of DNA. He was the director of the Human Genome Project and now the head of NIH. And these are some of the things that he has written as he's observed creation, again, God's activity in it. By learning the language in which God created life, we're gaining ever more awe for the complexity, the beauty, and the wonder of God's most divine and sacred gift. It is humbling to me and awe-inspiring to realize that we have caught the first glimpse of our own instruction book, previously known only to God. So the biosphere is just absolutely the supreme evidence of God as a creator. This is the geologic time scale that I showed you with just the names and the ages before. But in this part of the diagram, then some of the different species are shown over here on the left, just as a characterization of the changing biosphere through geologic timescales. And this one includes the big, gigantic extinction at the end of the Permian coming into the Triassic, and the extinction that I mentioned at the end of the Cretaceous that was the extinction that included the dinosaurs at the end of the Mesozoic. And just a reference back to this extinction at the end of the Mesozoic and the one that I pointed out before back there at the Permian. All right, let's look at Pangea just a bit. I have this slide included because these animations were made by Professor Tanya Atwater at University of California, Santa Barbara. And I got permission to use them and show them, being careful to give that attribution to her. So I have that reference where those can be found in her Facebook page or on her website that she's prepared and has lots of these kinds of animations. So 180 million years ago, the continents were together approximately like that. And as the core was heating up the mantle and the mantle's moving, it gradually drives the continents apart. And so that's a quick view over the movement of the continents over the last 180 million years. And whenever the times are that you might see this, watch in particular India crashing into Asia, because that is representing basically the process at the surface of formation of the Himalaya Mountains. And it's hard to imagine that happened over about a 10 to 20 million year period as it first began to touch that southern part of Asia as it was crashing into Asia. And it's hard to imagine the number of endless earthquakes that happened over those tens of millions of years to form that. And in fact, that process is still continuing because Mount Everest is still rising a couple of inches a year because of that activity. And on earthquake maps, it's evidence that, and we hear about those earthquakes as readily as we hear about the earthquakes along South America and elsewhere around the world. So a schematic of the method of what's happening. Down here in the beaker that I have as representing in the laboratory, if there's a Bunsen burner that's heating the water, the hot water rises and it convects inside the beaker in a manner like that. And that heating drives the process. Well, likewise, the liquid outer core of the Earth is basically the burner that heats the somewhat plastic mantle rock material of aluminum silicates, causing segments of it to rise. And as it rises up in the mantle, then it diverts and breaks continents apart, ultimately making ocean basins. And so these convection cells are an ongoing process. Process continues. The mid-Atlantic ridge continues to separate somewhat. The west coast of California, the Pacific plate continues to move northward. And we've known from the tremendous earthquake and tsunami over in Japan that that Pacific plate continues to dive in under Japan. There's a map that shows the motion of the plates where they separate on the mid-Atlantic ridge. And there I have the big arrow showing where India has crashed into Asia. This is a map that shows the plates also, but added to it are yellow dots that represent all of the earthquakes over about magnitude 5 that have happened over a 10-year period. So it really gives a representation of where the most significant earthquake activity and plate tectonic movement occurs. Even over the last 10 to 15 years, we've certainly heard of earthquakes that have happened down here along the western coast of South America, earthquakes in Chile. We had a very disastrous earthquake here in Haiti, influencing the Caribbean plate. As I first started teaching the classes in the oil industry to non-geologists about 15 years ago, that was not too long after the big tsunami quake that hit basically Southeast Asia and caused that huge, huge, huge impact and destruction around Sumatra. And some of that shockwave of the tsunami got the whole way across to India, and I think some of it even reached over to Africa. There's the series of earthquakes that are continuing to occur from India crashing into Asia. So on the north side of the Himalayas, on the Tibet Plateau, lots of earthquakes continue. And we had one that hit Tibet within the last 4 or 5 years that was quite destructive. And then of course there, the blue arrow would be about the approximate position for Japan, in that these earthquakes, that big earthquake that impacted the nuclear power plant was one that happened just offshore in the Pacific Ocean several years ago. Here's a schematic that shows the west coast of South America that helps you to see that context. So the oceanic crustal plate relative to South America and the Andes Mountains is moving eastward, and it dives in under the Andes Mountains. And as that crustal plate gets carried down deeper, it is the heat and the depth heated up, and it's the source of magmas then that squirt gradually up through the continental crust and form the volcanoes that are part of the Andes Mountains, up and down the whole backbone from down in Patagonia the whole way up to Colombia. So there's just a summary then, or the diagram then of plate tectonics. So plate tectonics demonstrates God's divine nature in several ways. It gives the opportunity to promote this paradoxical adversity of biospheres and different ecosystems. And the movement of plates helps to maintain equitable temperatures that are a necessary requirement for animal life to exist. So, summary then, say, of some of these important points about that were made in Improbable Planet. The magnetic field protects us from life, and plate tectonics help to maintain conditions that we can have stable life here on the Earth. A couple of quotes from Hugh Ross in the Improbable Planet. He has written, "The first page of the Bible really caught my attention. Not only did its author correctly describe the major events in the creation of life on Earth, but he placed those events in scientifically correct order. The ideal place for any kind of life as we know it turns out to be in our solar system like ours, within a galaxy like the Milky Way, and within a supercluster system like ours. In other words, we happen to live in the best, perhaps the one and only neighborhood that allows not only for physical life's existence, but also for its enduring survival." So the summaries, I remember 15, 20 years ago, I was thinking, well, there are probably many planets and there might be humanity somewhere else in the universe. But gradually, as I'm hearing more about the incredible uniqueness from astronomers, and then I think about the uniqueness of this Earth as a geologist, we may be the only one. And of course, we'll never know that. So that's my story about plate tectonics and the uniqueness of God's creation with respect to the Earth. Do you have questions there? Should I stop before I start on the Grand Canyon?
Ken, I only can say I loved your diagrams.
Thank you. That developed because I had these, because I've had 15 years teaching to non-scientists when I was teaching those classes in the oil industry to people who did not have geology or engineering degrees. So I very deliberately practiced not using fancy geologic terms, but to get it to people that can understand, and emphasizing the freedom to ask questions. Anybody else? Yeah, go ahead.
I have a question. Where are the uranium, the potassium, and where are those located in the interior of the Earth?
Okay. All of the elements, they're going to be mixed in with the rocks at different concentration based on their geochemistry. So the half-life of uranium is 4.5 billion years. The half-life of thorium, 232, I forget, but it's in the billions of years. And the half-life of potassium 40 is 1.3 billion years. So those half-lives are long enough so that these three radioactive atoms were part of the solar dust or the cosmic dust, the supernova dust or the cloud of dust that accumulated when God formed our solar system. So they've been there all along, but continuing to decay away. So they're mixed in with the rocks based on their geochemistry. And so they're scattered through the entire mantle, they're in the crust, and they're concentrated in different areas. Does that help? That is, they're not concentrated uniquely by themselves. They're scattered among the igneous and metamorphic rocks that we have on the Earth and among the sedimentary rocks.
Okay, thank you.
Yeah. Mm-hmm. Another question, any other questions? All right, well, let me go ahead and talk about the Grand Canyon. And then once we get done with that, I'll break out of the screen share and it'll be open to plenty of other questions. So as Bob has mentioned, get started about 10, 12 years ago now to write a book about the Grand Canyon, and I'll give you a little context why. We deliberately gave a title to it, a subtitle to it, Can Noah's Flood Explain the Grand Canyon? And the issue tends to be, well, let's see, I'll first talk about the lady that triggered the idea. This is Carol Hill, and she's a geologist who's a Christian and lives and works in Albuquerque, New Mexico. And with other professors at University of New Mexico, they've been doing research projects about the Grand Canyon for decades. So Carol Hill became aware that the Grand Canyon was sort of a showcase for flood geology that was initiated and triggered by a group of Christians who believe that the earth is young and that Noah's flood formed the Grand Canyon. In activity, they've been taking Christians down through the canyon for numbers of years on canyon trips, describing conditions that they make the claim that this comes from Noah's flood. And I will describe some of those features that they've mentioned. They also have trucks like this or vehicles like this where they'll give tours on the rim of the canyon, describing their belief that the Grand Canyon was formed by Noah's flood. The gentleman there beside the vehicle actually is Tim Hebel, who was one of our co-authors of the Grand Canyon book. So he must have been able to get over by the truck with our Grand Canyon book and hold up and have, I guess his wife took a picture of it. Obviously the drivers almost certainly were not there at that time. The flood geology community has written a number of books. In this case, there you see 4 with the title Grand Canyon, and the one in the lower set even referencing directly the word flood geology as one of their publications. So in the book, the book is written as a science book, not as a theology book. So we concentrated on the science, but we have to, of course, give the definitions and description of what flood geology is. So in part 1, we describe what flood geology means and its time frame. And then we give the time frame of modern geology. And the book is done by a group of 11 authors, and 8 of us are evangelical Christians in the church community. We had several folks that we invited to participate in doing the book who were not in the faith community because they had specialty expertise on a particular topic that we needed, and they were willing to cooperate with us. But the motivation for the book is by those of us who are Christians to basically give a book written for the church, expressly for the church, to help to describe a truthful description of the Grand Canyon. Now, at the time when we were working on it, and one of the individuals that was my mentor and encourager in Solid Rock Lectures was a theologian who is well known, and we asked him, and he agreed and went ahead and wrote an endorsement for us. But in the early days, as we were working on it, he made a statement to me. He said, "Well, you really should give the title as a statement, not as a question. That is, we should have," he felt and recommended that we should write it as "Why Noah's Flood Cannot Explain the Grand Canyon." So I wrestled with that question for a number of days. I even was attending a meeting of InterVarsity with hundreds of students at a meeting in St. Louis. So I had 2 covers printed out, on sheets of paper. One that said, "Can Noah's flood explain the Grand Canyon?" expressing it as a question, and then also one that made the statement, "Why Noah's flood?" And I showed it to people, and I said, if I wrote it as why Noah's flood cannot explain the Grand Canyon, do you think you would pick it up and read it? And I asked the folks, you know, if they had happened to have a young Earth view and a flood geology view. And one person just admitted, said, no, if it said why not, I probably wouldn't ever even buy it. Wouldn't read it. And then a couple of days later, as I'm processing this and praying about it, I realized we really had to be posing it as a question, even in spite of what the theologian said, because we did not want to come across to the church saying, please take our word for it. We wanted to give the context of, here's how we do science. We ask questions, and then we gather lots of data, and then we make the best reasonable inferences of what we see. So ultimately, I'm really glad we did it that way. We have endorsements from Bible scholars and theologians. Jack Collins at Covenant Seminary. Paul Copan is at Palm Beach, Atlantic University. Wayne Grudem is at Phoenix Seminary. Ken Keithley is at Southeastern Baptist Theological Seminary. So we have those. In the book, we also have a group of geologists that are well known, because we take this book to Geological Society of America meetings also to help the geological community be aware that we've written this. Part 2 is a section where we talk about sedimentary rocks and how sedimentary rocks can give us a story of geologic history. And geologic time is one that we identify when there's a layering of rocks. Relative time is indicative of the oldest rocks are on the bottom and the youngest rocks are on top, just referred to relative age dating without any specific ages. So as we look at the Grand Canyon, the older rocks are in the inner gorge and the youngest rocks are up at the top. Now, geologists identify and describe geology by formation names for convenience of communicating with each other. So here I'm just going to use 2 names to give an identifier. They're right in the middle is a formation called the Redwall Limestone, where I have this blue arrow that's pointing down there. And one other name that I'll mention here is the Coconino Sandstone that is right below the top, and it's that white layer. And you can see that the white layer extends over a long distance. The whole field of view of this photograph is that distinct white layer of the Coconino Sandstone up near the top. So here's the geologic time scale, which I showed you before. And I briefly mentioned that the Grand Canyon itself has Paleozoic rocks. This is a diagram from the book across a 2-page spread. And so here the Grand Canyon sediments are the Paleozoic. And the flood geology community describes this as happening in the early days of the flood. That is deposition of this 5,000 feet of sediments in only 6 months, about 150 days. All right. Then the geology of that part of northern Arizona and Utah includes Mesozoic sediments that go the whole way up to Bryce Canyon in Utah. And those were sediments that would have been up on top of this, all this area, were otherwise eroded away over the millions of years of the passage of time. But the flood geology community claims that all these sediments were deposited in the late stages of this year of Noah's flood. And then in addition, somehow, as the water from the flood was receding away, it also carved the canyon. So that tends to be their description. One of the factors I can point out very easily right here is that, see all these little black dots that are just sitting a little bit above that trace? Those are formations in which we find dinosaur bones. So the dinosaur bones are only in the Mesozoic. Here in the Triassic, Jurassic, and Cretaceous, there are no dinosaur bones at all down in the canyon. There are no mammal bones down in the canyon itself. So flood geologists have to describe this, and they basically say, well, the mammals and the dinosaurs could run away and get up dip, or get out of the way of the flood. So that's the nature, somewhat the nature of their argument. Here's a piece of evidence that it was not one continuous flood, in that of the geologic timescale that I have identified over here on the left, two formations, the Ordovician and the Silurian sediments, are completely missing from the Grand Canyon sedimentary sequence. So there's the Cambrian, and the first formation right at the base of the canyon that you see from the south rim is a sandstone called the Tapit Sandstone. That's Cambrian rocks. Then the area was not an area of deposition. It was being eroded. And so during Ordovician time and Silurian time, there was no deposition of sediments in this part of what is now Arizona. There were Devonian sediments. There's a window of no missing sediment. Mississippian sequence is there. And again, there's a gap with lack of sediment. But the most dramatic one is that Ordovician and Silurian are just completely missing. One of our chapters, I managed to keep my name off the cover of the book, so I was not a general editor, but I'm a co-author of two chapters, and one of them is Broken and Bent Rocks. Brian Tapp became a very good friend. For many years, he was the chairman of the geoscience department here at the University of Tulsa, and he specializes in rock mechanics. He's a tectonics guy. So he understands the way rocks get squeezed and broken and bent and things like that. The flood geology community takes individuals, as I said, on their river trips through the canyon, and a geologist basically takes them to this location, which is in what is called the Carbon Canyon area, and he shows them this fold, and he says, this fold was formed when those sediments were soft because those rocks do not have fractures. And that's the story that he tells these non-scientists on the river trips. But in fact, that whole sequence has dramatic fractures, which my colleague, Brian Tapp, even looking at a picture, can physically see the fractures. And because he understands the folding process, he's aware that these rocks were hard when they were folded and bent because of the orientation of the features of the fractures. And because those two red arrows are at a slightly different angle, when hard rocks get folded, the folding is influenced by the constituency of whether the rocks are harder or not as hard. So the behavior of the rocks in the folding process tells Brian a lot about the conditions under which the folding took place. Another geologist stands on the rim of the canyon, and in the movie that is Genesis History, he used this phrase, looking between the layers, we don't see erosion or significant channels. Whereas in our book, we physically show this example of a very large channel that's been cut into the top of the Redwall limestone, and that channel that was cut in the Redwall limestone is filled in with a different formation here, and it's referred to as the Surprise Canyon Formation. And there's a mixture in that Surprise Canyon in that there are land fossils and marine fossils. So it's not just one big pile of the same thing. So it shows a transition of ecosystems as that area then was covered with water and then filled in, that big valley filled in later during deposition. And then mountains have arisen since the flood. The flood geology community gives a description that plate tectonic movement of Pangaea that I showed you a few moments ago all happened during Noah's flood about 4,400 years ago. So really challenging it just doesn't fit reality. For radiometric dating, it's fairly common that you can read a flood geology or young Earth creation material, and they'll make the claim that radioactive half-lives must have changed in the past. And Roger Wiens, in the chapter about radiometric dating that we have in the book, makes the suitable comment, it's true, if radioactive half-lives and all the radioactive decay that is included from 4.5 billion years decay of the uranium, the potassium, thorium, if all that happened in a few thousand years, basically the surface of the Earth would be molten, and we would not be here, that's for sure. So this is one of my favorite diagrams that's in the book. Comments about the book. Scott Buchanan is a retired chemist from a major oil company. So he is a student of any kind of science, but not a geologist. He's a chemist. And he wrote for us, "This is one of the best introductions to geology I've ever seen. This section alone would make this book a worthwhile purchase, even if one had little interest in creationism." So he found it, so I sometimes put it, if you want a nice introduction to geology and don't want to go to the local junior college and take Geology 101, this gets you well along the way on how we do geology at a continental scale. One of our editors has published a book himself and has his own books in the Grand Canyon bookstore, and that gave us a window to be able to have basically a book signing event there, which we went to a Memorial Day weekend in 2016. And there's our book on the Grand Canyon bookstore shelf. And that was a delight to be able to be there and visit with some of the staff at the Grand Canyon. Here, one of our reviewers made these comments. "This book beautifully, graciously, and thoroughly confirmed that the Earth actually is very old. It offers grace, tact, and kindness toward people trapped in the young Earth idea that's marketed by flood geologists. I'm so very grateful to the authors for writing this book." So that kind of a phrase helped to ease my angst over the endless hours that I poured over the book and helping to get it published. But I knew it was a task that the Lord had given to me, and I hope I did it with gentleness and grace. We do have a chapter there on radiometric dating written by Roger Wiens. Roger Wiens' article that he did about 20 years ago on radiometric dating from a Christian perspective is the most downloaded file or article from the American Scientific Affiliation website over 20 years. And we were very fortunate that he was willing to write this chapter for us. And I like the title he picked. So just how old is that rock? So he gives a description of how it works. And for the case of the Grand Canyon, some of the metamorphic rocks that are down below the sediments that you saw are older than the Cambrian. And so here he's plotted 4 different values of different radiometric dating methods and the degree to which the amount to which they agree together, how close they are together, or maybe they're separate. Well, the two here at the top basically are the same values within the error bars, which you can see. So there's uranium lead. This one is called samarium neodymium. So those two basically agree with each other. Rubidium strontium's a little bit less. And potassium argon is notably less. And we have reasons to understand that it could be less because when the rock was first formed, there was a time when all of these methods at a certain window would probably give the same result. But when a rock is formed and then say a couple 100 million years later, it's heated up quite a bit. When a rock is heated up, argon is a noble gas. So in hot rocks, argon is prone to dissipate and escape out of those rocks. So there's reasons to think that there would be less argon there that would have been produced over, say, the 1.2 or 1.3 billion years of this particular, from the formation of that particular rock that's identified. Just share with you, the heavens declare the glory of God, and the Grand Canyon is a spectacular display. And there's a URL where you can find the book and see a summary of it. And I will send this in an email to Bob so that he can share it with you.